Hello, let's continue our Sudoku adventure with Zona di esclusione circolare. All right, it's by rockratzero. This is a non-consecutive puzzle, so hopefully you realize that there is a little hint up, reminder up here that it's non-consecutive. But yeah, you don't see too many non-consecutive 6x6s for reasons I may talk about at the end of the video, but doesn't matter right now. Let's go over the rules. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have counting circles. That's these circles here. So counting circles count how many times a digit appears if it appears in the circle. So that's a really weird way to say it, but if a 2 appears in the circle, for example, that means there are exactly 2 2s in the circle. So we can't put a third one and we can't omit one, right? If there is a 2. If there's no 2s, then there's no 2s, and that's fine. But if a digit appears, it appears that number of times. So this doesn't work, but let's say Sudoku allowed this. We could have 2 3s in the corner and then a 3 here, and this would be 1. So we'd have 2 2s, a 1, and 3 3s. So that would be one valid way to do it if Sudoku allowed us to put 2 3s in this row and box, which it does not. All right, I'm trying not to give the answer. I don't know what the answer is, but I try not to give the answer in my rules explanation by accident. All right. We also have non-consecutive. So every pair of adjacent cells, vertically, horizontally, as long as they're orthogonal, may not be consecutive. So if this was a 2, then that excludes 1 and 3 from all of these cells. They cannot be 1 or 3. This would not be allowed. This would not be allowed. This would not be allowed. This would not be allowed, etc. So just any pair of cells that share an edge may not be consecutive. It's disallowed. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, we're going to start with counting circles. So there's a little trick. If you think about counting circles in the right way, this little trick really helps. And we actually did a whole theme week on counting circles. I don't remember when, but you may be able to find it in the spreadsheet. And so I explained it every day for 7 days in a row. But anyway, here's the explanation. So because when a digit appears in the circles, it appears that number of times, any digit uses up exactly that number of circles. So if we reverse that, we can say that the unique digits that appear in the circles sum to the total number of circles. Remember my example here, which didn't work. 1 plus 2 plus 3 is 6. And you'll notice that there are 6 circles. And so that's always going to happen. So what we need here are we do need 3 distinct digits that sum to 6. And the only way to do that is 1, 2, 3, just like that. And so all of the circles are from 1, 2, 3. Now we know that this 1, 2, 3 must contain a 1. Now, why? Let me explain real quick. Why did it have to be 3 unique digits? Well, because we can't repeat any digits in this box. So we need at least 3 digits. And we know that 1, 2, 3 is kind of the only way with 3 digits to make 6. And we can't do 6 with 4 digits. So this uses up the 1, meaning we can't actually put a 1 outside of that box in these circles. And this 2, 3 pair uses up the second 2. So this has to be a 3. That makes this not a 3. Now, this is a nice little non-consecutive trick here, where if we have 2 consecutive digits in one cell in a non-consecutive puzzle, then it eliminates both of those digits from the digits that are next to it. And so 1, 2 here eliminates both 1 and 2, right? If this was a 1, this would have to be a 2, and that would be consecutive. If this was a 2, this would have to be a 1, and that would be consecutive. But unfortunately, we already have a 1, 2, 3 triple here, so this is just down to 4, 5, 6. So that doesn't really help us, but this 2, 3 pair may help us. Well, no, because we already eliminated 2 and 3 from all these cells, so I guess that's not helpful either. Well, okay, but these 2 cells definitely see the 2 and definitely see the 3, right? Because they see the entire 2, 3 pair, right? If this was, say, a 4, then it's going to end up next to a 3, because one of these 2 will be a 3. Whether it's 2, 3 like this or 3, 2 like that, the 4 will be next to it. So we can't put the 1 or the 4 here, making this a 1, 4 pair. And then this is the remainder 5, 6. Okay. And the thing I was going to talk about with non-consecutive, I'll leave till the end of the puzzle, because I don't think we will need to use that for an adventure puzzle. Anyway, next to this 3, we can't put 2 or 4. So I'm going to shamelessly put 1, 5, 6 here. Let's see, what else can we do? Okay, we can't put a 2 next to this 2, 3 here. So this is not 2. Is that helpful? I mean, I don't know if I want to write 1, 1, 4, 5, 6, but I guess I can. All right, so 1, 2, 3. This is another little trick here. This for this cell and this cell. That might actually be helpful for this cell more, which is that it can't be a 2. Because if it ends up being a 2, then the 1 or the 3 that this ends up being will be consecutive with it. So you can kind of think about it as 1 eliminates the 2, 2 also eliminates the 2 by Sudoku, and 3 eliminates the 2. So this can't be a 2, and that leaves 2 in one of these two cells. Now, when we corner mark a digit like this, notice these two cells are adjacent. They share an edge. And so now we can't put a 1 in either of these two cells. Because if we were trying to put a 1 anywhere, it would force the other one to be a 2, and it would be next to it. And we also can't put a 3, but there's already a 3 in the box. So, by the way, this isn't 2. And so the 1 ends up over here. I don't know if that's helpful. So instead of that, I'm just going to put 2 and then 4, 5, 6, I guess. All right. What else am I missing here? So 1, 2, 3, 4, 5, 6. Huh. Okay, so we've limited the 3 to one of these two cells, and both of these see, wherever the 3 ends up, both of these are next to it. And so these can't be 4, and so that places the 4 here. Now that means this can't be a 5. And now the 4 can't be next to this 3, and so this ends up being the 3. Okay, so we're going to need a 4 over here, and it's not next to the 3, so the 4 ends up over here. This one, too, eliminates 1 and 2 from this cell. We didn't know it couldn't be 1, so 1's in one of these two now. Now we do know it can't be 1. So it can't be 1, 2, or 3, so it is from 4, 5, 6. What can we do with any of this? 4, 5, 6 eliminates 5 from the digits next to it. So these can't be 5. 2, 4, 6, interesting. Let's see. Am I doing this right? 3 is down here. So this cell in the middle can't be a 2. Because if the cell in the middle were a 2, it would have to be next to a 3. So if this isn't 2, then it's from 1, 3, 5, 6, I guess. The 4 up here eliminates both. Oh, I guess it eliminates 3, but it eliminates 5 from these two. We talked about that pattern already. So 5 can't be in these two. Then these are from 1, 2, 4, 6. I'm not getting anywhere with this. Clearly missing something. This 1, 4 pair, is that helpful? How about this 5, 6? This can't be 5 or 6. That seems like it might be useful. So this is only 1, 2, or 4. This 5 or 6 says this can't be 5 or 6. So this is 1, 2, or 3. Oh, but it can't be 1 because of the 1, 4 pair. So this is 2 or 3 only. That eliminates 3 from this cell. So this can't ever be a 3. 1 would force this to be 3. It couldn't be next to the 2. 1, 5, 6. The 4 is in one of these two. 3 being in one of these two doesn't seem to change anything. All right. What is next? Four, 5, 6. 1, 4 pair. Why am I not seeing what to do? This cell here can't be 4. We already know that. I mean, the 1, 4 pair already told us that. I'm going to fill out this entire column. We need the 2, 3, 5. Oopsie, not like that. We need the 2, 3, 5, 6. So we know these aren't the 3. And this isn't the 2 either. Ah, right. The 2 is eliminated from that too. So this is a 5, 6 pair. So this can't be, these can't be 6 because the 5, 6 pair. We're left with 1, 2, 4 here. And then 2, 3 eliminates 2, 3 from the cell next to it. And so this 5, 6 now makes this have to be 2. So that's 2 and that's 3. Okay, now, gotta be careful. 2 eliminates 1 from here. This can't be 2. 2 eliminates 1 from here, so this is 4 and 1. Okay, 4 can't be next to 3, so that's 2, 3. 3 in the corner? Okay, that's not a 2. 2, 4, 5, 6. Oh, 5, 6 eliminates 6 from here as well. Let's see, this is a 1, 6 pair. When did that happen? So these can't be 6. That's a 4, 5 pair, so this has to be 2. I just wasn't paying attention to that, I guess. Don't know when that happened. 1, 2, 5, 6. This can't be 1. It's down to 2, 5, 6. Oh, interesting. I don't know if this is helpful, but it's kind of interesting that this can't be 1, 2 because of this 1, 2 here. This will take up one of them. And so one of these has to be a 5, 6, meaning it can't be a 5, 6 pair. And I think that places the 6. We probably don't have to do it this way. Almost certainly, but isn't that neat? I mean, let me explain it more carefully. If I want to exclude both 5 and 6 from here, then this has to be 1, 2. And that breaks this cell. So we know that there's at least one 5, 6 in here, but you know you can't put 5, 6 next to each other. We can't do this. That would be consecutive. And so we need to put one of the 5, 6s elsewhere in this column, and it's only here that can do that. So this ends up being 6. I just think that's neat. That's 5, that's 4, that's 1, that's 5. We get the 4 and the 6 here. We get the 6 and the 2 and the 1, 5, 6, 4, 2. We get the 5 and the 2 here, the 6 and the 5. This is our 1. This is a 5. We get the 1 and we get the 3. And then we can just finish these. We need a 1 in this box. We need a 3 in the box, and then 4 and 6, 6, 4, and we're done. All right, so let me point out the very nice puzzle, Rockrat. I think that solved nicely. I don't know if this last step here was needed. I think there was probably plenty of ways to do it, and the reason I say that is because let me talk about the thing that happens with with non-consecutive every time. You will notice, let me just highlight the odd digits here. These are odd and these are even. This is not a coincidence. This must happen, or you swap the evens and odds, right? But this pattern will happen every time, unfortunately. And so you could immediately, like as soon as you know where one odd is, you know where all the odds are. And as soon as you know where one even is, you know where all the evens are. And so we can prove that. I haven't proved it in a while, but let me mess around. Maybe me messing around with it will actually help understand how you might approach proving something like this. So let's clear the grid and let's make this cell odd because it's gonna actually, sorry, let's make this cell even. It's arbitrary which one we pick. But let's say this is even, a 2, 4, a 6. So I'm picking this one because it's kind of the most powerful in the box. And if I remember correctly, it cascades downward. So if I were to try to put an odd digit next to it, a 1, 3, 5, let's see. Can't remember how this works. I remember proving it, but it took a little bit of doing. I might even have a video from a while ago where I did prove it earlier. So it's a mixture of trying to recall and trying to prove it again. But if we I'm gonna go find my proof. Sorry, I'm not gonna be able to, I know I wanted to show how you would prove something like this, but I don't think I can just sit here and do it. But I'm gonna go find the proof, and I will come back. Okay, I think I can take it from here. I read up a conversation I had a while ago about it. So the question is, where is the 3 gonna go in column 2? That's the first question we're gonna ask. It's gonna go somewhere, and without really losing generality here, it's gonna end up in one of these boxes. So let's say it ends up in this box, and again, without losing generality, we're just gonna place it here. So, and it would be the same result if we placed it here, but if we place the 3 here, then you'll notice none of the cells adjacent to it can be 2 or 4, just by non-consecutive. But the box needs a 2 and a 4, so they end up here. And again, this would happen to any box where you wherever the 3 goes. This is going to happen. Like if the 3 were here, then the 2, 4 have to go there. They have to go in the corners of the box that aren't where the 3 is. So we're not losing generality by doing this. Now between this 2 and 4. We can't put the 5 or the 1 because one of these will be 2 and one of these will be 4. So if this can't be 1 or 5, this ends up 1, 5, and then this ends up the 6. So we're always going to be grouping that 3 with that 6 there. And notice we do end up with all of our odds here and all of our evens here, which, you know, we can rope over to here, but we'll deal with that later. And now we can continue by asking, I think, where the 4 goes now in this column. So wherever the 4 ends up, let's say the 4 ended up here, which I don't think it can, but let's say, then in the where do the 2 and the where do the 3 and the 5 go? Well, they can't go here. So this would end up a 3-5 pair. And so we end up again between this 3-5, one of these is 3, one of these is 5. That's going to exclude both the 2 and the 6 from here. So this ends up being a 2-6 pair. And so you can see that no matter what, we do end up forcing the striping to happen again. There's more to it because this ends up being the 1 in this case, right? And so now the 2 digits left to place are the 2 and the 5, which are going to end up in that 3rd box. And we can kind of mix these boxes up in different ways. And let's see, transmit it down to here might be a bit more difficult. So wherever the 2 ends up, we can't put the 1 or the 3, right? So it kind of has the same effect. Let's say the 2 ended up here. Where, in fact, in this case, it would have to because the 5 can't go next to the 4. But anyway, the 2 ending up here, we now need the 1 and the 3 down here. So basically, whatever even digit we place somewhere, in the corners of the box, you're going to have to put those 2 digits it includes, and those 2 digits are both going to be odd digits. And in this case, now that we're down to 2, 5. We had to place the 5 in the other one because we had to use an odd and an even for the 3, 6 and the 1, 4. And so now this ends up being a 4, 6 pair. So at the very least, you know that you're going to end up always striping the even and odds here. And then by roping, you end up striping them this way. Even if that's the only thing you remember, that's still enough to kind of show that has to happen. I think that there's more to it, but I think that's enough to just kind of trivialize a lot of non-consecutive puzzles. So if we were to start this puzzle over using that information, we know this is 1, 2, 3. We know this was the 3 and this was a 2, 3 pair. We started with that. So now knowing this is a 3, we now immediately know that these are odd, these are odd, these are even, and these are even. And so we can just immediately put 2, 4, 6 here, the 1, 5 here. We can put 2, 4, 6 here, and the 1, 5 here. Now the 3 can't be next to 2 or 4, so that does force it to be next to the 6. All right, and so let's see. So we know that the 4 would be forced to go with the 1. I don't know if that's helpful at the moment. Let's see, where do we go from here? So this 2, 3 eliminates 2 from there. we basically want to try to prove, I mean, we know this is 4, 5, 6. Oopsie. This is 4, 5, 6, so that's not a 6. We know the 3's in one of these two, so these aren't, these aren't 4. That places the 4 here. Now that we know that's 4, we know all of these are even, all of these are even, all of these are odd, and all of these are odd. And so now this can't be the 3, so that places the 3 there. Actually, this has to be 2, it's the only even. This is 1, this is 5 to be odd, this is 6. We get the 4 and the 2, we get the 1 and the 5. And now we know what all these pairs are, which is going to be extremely helpful. We know this is 2, 5, we know this is 3, 6, and we know this is 1, 4. And we could have proven more about non-consecutive. There are very few non-consecutive solutions. So is there something we can do? Let's see. The 3 looking down tells us this is the 5. So now we know this has to be 3, 1, and this has to be 2, 6, 4. So it just immediately resolves it. That makes this 2 and 3. We know that these are even. We know these are odd, and we have the whole thing colored now. Next to 3, we can't put the 4. So this is 6, and this is 4. Next to the 5, we can't put 6. So this is 2, 4, and 6. Next to the 2, we can't put 1. So this, I missed the 3 here. This can't be 1 or 3. So this has to be 5, giving us the 1 and the 3 here. And then down here, we need the 1 and the 5. So that's 1 and 5. And now we should just be able to finish because it's naked singles for a final box. So this is the 3, this is the 1, this is the 5, and this is the 6, this is the 4, this is the 2. So as soon as you know that in a 6x6, you have this even odd striping, even if you don't know much more about it than the even odd striping, it still basically trivialized this puzzle that had much more interesting logic that we were finding if we didn't know that meta information. So that's why, unfortunately, 9x9 non-consecutive is much, much more interesting. Still very highly constrained. In fact, you only need 4 givens in a 9x9 to potentially make a non-consecutive unique, which is kind of crazy. I've never found a 4 given non-consecutive that's human solvable, but they are unique. So you end up having to add more information anyway for a human to solve it. But with 6x6, unfortunately, because of the way the boxes are, it kind of disrupts the ability to have an interesting puzzle once you know that. Cool. Well, I hope that was interesting. Let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.